so make sure you go to Google Classroom and check out what I did yesterday. There's a lesson that I posted. It's just the very last part of the notes from, I guess it's homework day 14.
And the homework's like 4 pages long.
All right, so make sure you check those out and fill that in because it's important that you get that done. And there's a spot where you can turn in your homework or you turn in what you wrote down. So that's my way of saying, hey, they actually did it. Yeah. So you might want to do that. Okay. Yeah, there we go. Here's where we are. Now we're going to start making connections between f prime of x and f of x. This is super important. And we kind of already did it. It was on one of our homeworks that we just went over it with Wynn and everybody. But where you just kind of figure out what's going on. So let's think about that. If f prime, okay, if f prime of x is equal to 0, what's going on the original graph?
It's flat.
Okay, it's flat there. What else did you say, Wynn?
Relative maximum.
It can be a relative max or min, yes?
I'm being a line.
Oh, you're being a line?
No, if the slope is 0.
No, yeah.
This line, horizontal.
Yeah, what would this line be?
That's vertical.
Yeah,
That would be infinite.
I did this line first, and then you looked at me and looked away, so I thought I was wrong. So
Oh, I didn't see
it's
that.
like a little hill and valley.
So what Ashley is saying is right.
It'd be
It
like that.
has a horizontal.
Would it be like a, what is it? It starts with a
Ashley
B.
said it had a vertical.
Well, I was
Oh,
right
did
the
she?
first time.
Oh,
I was right
I'm
the first
sorry.
But you changed your answer.
Horizontal tangent line
Why are you like
that may or may not produce a relative max or min.
So wait. Oh no, wait, that makes sense. I was gonna say, so wait, there can be like a flat one, but it not be the
Yes.
maximum.
For example, I'll write it here and then I'll erase it. But right here is a horizontal tangent line. It flattens out right there just for a second, but it's not a max or a min.
Yeah.
it's 0.
Yeah. So
Well,
That's
even
what-
though it's actually 0, it's like a 0.
But like a negative 1 would be lower than 0. Because we're making
okay, what if the derivative is greater than 0? What's going on with the f of x?
It's
Increasing.
Increasing, yes.
Yes, that's positive. We need
Why are we trying to recreate when we learn how to make lines?
because I'm bored.
I'm sorry, you're bored. If the derivative is less than 0 or negative, what is f of x?
Decreasing.
Decreasing.
It's hurting me.
I hope it's not hurting you.
What is it, Mom?
It's hurting my soul.
when it changes from.
Yeah.
And my phone.
What if it changes from a positive slope to a negative slope?
Hold on. Wait, changes.
Wait, we just ran
Like
over
this?
that.
It looks like
Isn't
this.
it just decreasing?
So if the derivative changes from positive to negative, what had to happen?
It went from like the relative max to wait.
You're
Oh, it's
almost
going up to the relative max.
yes. It creates a relative max on f of x.
I was gonna say, I know what's up there. I don't know how to explain it.
No, it'd be like this one.
Ah.
No, but yeah, we're doing it this one.
So it has a relative. They'll also sometimes call that local max. Same thing.
A local?
Local.
So that'd be this one.
Buy it low.
But for
It would be,
This
for
one's thinking
example,
about, like, how you're
you had
looking
something
in
like
the
that.
grocery store.
So on this side, it's a positive
Okay.
slope.
I got
This
it.
side, it's a negative slope.
Cool.
So it has to have a max.
We're on this line right now.
It has to.
Yes, if the derivative changes from positive to negative, it has to. But if it has a horizontal tangent line, then it doesn't have to. You're trying to think of one that doesn't?
Yeah.
Okay, you think. If it changes from negative to positive, what does
Relative minor.
relative what?
Min.
Has a relative minor.
Min.
Min. Minimum.
Relative minimum.
That's a relative minor. That's relative minor.
She's thinking band.
Minimum.
Am I?
Major, minor, I don't know.
Yeah, I mean that is a thing. But like, what does that have to do with max? I don't know.
I don't know.
Come on, I'm fried. I will go.
Okay, so here's f of x. We want to draw a possible graph of the derivative.
You can hurt my eyes.
Ooh.
It's because I was trying to like.
Are you listening? No.
Yeah.
Possible graph, there's more than one, of f prime.
Mm-hmm.
So let's start with, to me, the easiest places to start are the zeros. So I have, at what points on this graph do I have horizontal tangent lines?
Point number 3.
1, 2,
If you're going from the left.
6 and 8.
I can't see.
1, 2, 3, 4.
I'm taking the first one.
Guys, you have your own graph, right?
Yeah.
1, 2,
I have 4
3,
too.
4, 5, 6. No.
Negative
This
4.
is f prime.
-4.
Oh!
Sorry.
I'm sorry. I'm going backwards. I was thinking this was f prime.
No. -4 too.
F of x. So, still, where do I have a horizontal tangent line on this f of x?
Negative 4, 2.
Yeah.
Right here.
Negative,
-4, 1.
negative 4.
My way was a lot easier.
5.
1, negative 4.
Okay, I see negative 4, 2. I don't see negative 4, 1.
Yeah,
It's-
I meant 1,
It's 1 negative 4.
Oh! Okay, I was like, what? And where else?
5, 4.
Is that 5?
Yeah.
4. 5, 4.
It's 5, 4.
Okay.
Not me.
So, when I take the derivatives of those points, I get 0, right?
Yes.
So I'm going to have a 0 at, what was that point? 1, 2,
Negative 4,
3,
2.
4. Negative 4. So I have a 0 at negative 4. I have a 0 at
1.
1.
0 at 5.
And a 0 at 5.
Cool. Now what?
Yeah, now what? Okay, so now let's go to the left. On the left of this first horizontal tangent,
Mm-hmm.
I have these tangent lines.
Yes.
They're pretty bright.
Are they positive
Yes.
Yes.
or negative? Okay, they're positive.
Yes.
And are they increasing or decreasing?
Increasing.
No,
Yes.
like
Yeah,
their
they're
slopes.
getting bigger.
Like their
Why?
slopes.
Their slopes are decreasing.
Yes, they are.
Why?
Well, because I start off with, like, down here, it's almost a vertical line.
Oh.
And as I go to the left, it gets less and less vertical.
I thought you meant like
Oh, yeah, that makes
Getting
more
bigger.
sense.
So, it starts with a higher, and then it decreases. So, and they're positive. So it's positive, and it's decreasing. So it can look something like that.
Okay, yeah, that makes a lot more sense.
Okay.
I was just saying, that'd be kind of weird.
So for these, it starts off high. So that's the high, and then it decreases. And there should be an arrow there because it continues. And then it goes.
that made no sense.
What did you just say?
It hits 0.
And then it goes.
Now these.
Well, can we figure it out from here?
Oh.
No.
Well,
Well, that's
these
gonna go
are
up and
negative, right?
Yeah, they go under. They go under the ground.
Okay. Then that doesn't matter. So they're negative. They're negative because they're slanted this way.
It's gonna look.
And so they start.